All right, first thing I want to point out to you guys is if I have something that looks like this, which most of you have in this room, some of you still have yet to get one, but on your graphing calculators, this is your viewing window that you have. Some of the graphs that you've done so far, and you've put them in your calculator and they've looked like that, and you think, oh, that's so awesome. It's a great window. But what's going to happen on something like this today is that you have that standard window and then all of a sudden this thing really looped around this way and looped around that way, and you have no idea that it did that. So there's going to be something that I show you now called end behavior that's going to help us determine what's happening on the ends of the graph. So that way you'll know whether or not your window is good enough. Okay? So with end behavior, there are 4 different criteria, things that happen. Okay? We're going to walk you through all of them. I'm going to give you the technical terms of it and then put it in easier terms after that. Okay? So end behavior is the thing that we're going to deal with on the first part. And again, there are 4 different types of end behavior. There are 4 different categories. Okay? The first thing is if your degree, we'll go with odd first. If your degree is odd, bless you guys. What does it mean to be odd? I'm talking about the degree, and the degree, remember, is the highest exponent. So, what does it mean to be odd?
Not even.
Not even, like 1, 3, 5, 7, and so on. Okay, so that degree has to be odd. Then the next thing I'm going to look at is the lead coefficient. And we talked about that last Friday. The lead coefficient is the number in front of the one with the degree. So if your lead coefficient is positive, we'll do the positive one first. And I can't spell this morning. Or ever, for that matter. Spell check is awesome for me. Okay? So the first thing we're going to look at is if your degree is odd and if your lead coefficient is positive. So an example of something like that would be 3x to the third plus blah, 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 whatever the rest of that would be, don't care. Okay? I'm looking at this is the degree, this is the lead coefficient. Those are the 2 things that I'm looking at. Odd number, positive front. So far so good? Okay. So here's what's going to happen. As x approaches negative infinity, which again, the first time I ever saw this stuff, I was like, what does it mean by negative infinity? I'll show you. I'll put it in terms that we can understand. Then your function approaches negative infinity. And as x approaches positive infinity, then your function approaches positive infinity. Now, right now, when you look at that, you might go, huh? I don't have a clue what he's talking about. But let me put it in easier terms that may help. When it says x approaches negative infinity, that means left. As we go to the left. So x approaching negative infinity is a fancy way of saying go left. And f of x approaches negative infinity, that's a fancy word of saying down. And as x approaches positive infinity is the fancy way of saying to the right. And as x approaches positive infinity, that is a fancy way of saying up. Now here's one other thing that somebody wanted to know last hour. F of x is the same as saying y. So your x and your y. So when I say f of x, I'm referring to a function. However, it's the same thing as y equals, or y. Okay? So here's what it's saying. As your degree is odd and your lead coefficient is positive, as you go to the left, the function itself, or the picture should go down. And as you go to the right, my picture should go up. Now, you've already graphed ones that have a lead coefficient, a positive, and an odd degree. You graphed lines for me already. Think about a line. A line is an odd degree because it's a 1. And when you had a positive slope, didn't it go like this? Uphill? Now the only thing that's going to be different is these things are going to turn around, but they're also going to be flowing uphill, the roller coaster ride. Okay? The next scenario. If the degree is still odd, and your lead coefficient is this time negative. If the positive one went this way, what do you think the lead coefficient is going to do? Or the negative one's going to do? Go the other way. So we're going to turn. So as x approaches negative infinity, your function is going to go where? On the last one, if it went down, and you said if it's going to go the other way, then it should go up. So positive infinity. And as x approaches positive infinity, or to the right, then my function is going to go where? Up or down?
I don't know.
Well, it was this for the positive one. Now you said negative goes the opposite direction. So on my right-hand side, where's it going? My right-hand side's over here. Which way is it going? Down. So again, in layman's terms, left, right, down, up. I want you to think about a line that you've graphed for me, I don't know how many times already this semester already. When we graphed lines, the highest exponent was a 1. That's an odd number. And when you had a negative slope, it went downhill. That's the same. It's the same thing. The only difference is when I have this, we're going to have more curves going on in here rather than just a straight line. But it is the same thing. Now what happens when the degree is even? Alex?
What's a degree?
A degree, to remind you from Friday, the degree is the highest exponent.
Yeah, that's a
Yeah. If the degree is even, what kind of numbers are even? 2, 4, 6, 8, and so on. You've already graphed ones that have an even exponent. How many times have you graphed a parabola in here so far? Right? X squared? Or this? Okay. Now, if your lead coefficient is positive, we'll start with the positive one first again. As x goes to the left, or negative infinity, which way do you think it's going to go? Do you think it's going to go up or down if it's a parabola? Okay, I got a couple people doing this with their thumbs up, and some person even said up. Right. Think about a parabola. For those of you who watch football, you probably saw this weekend at some point or another when your team or the opposing team scores a touchdown. Don't the officials do this? For those of you who have ever watched football before? It's the same concept. Then your function is going to go up. And as x goes to the right, your function is going to go where?
down.
Nope. It's a parabola. Both sides would do what? Go up. So left, right, up, up. And the last scenario is if your degree is even and your lead coefficient is negative. As x approaches to the left and as x goes to the right. What's going to happen if the lead coefficient is negative, do you think? I want you to think back to your parabolas that you guys had before. When I had a negative a, what did it do? Which way did it open? It opened down, right? So what should both ends go? Down. Negative infinity, negative infinity. So as we go left and right, we're going to go down and down. And those are the 4 scenarios that you're going to see. Okay? All right, now, before I go into anything further, I'm going to go back to that very first one where this whole thing went like this. That would be a highest exponent of x to the 4th. And of course, we'd have some other things happening in there. And we'd also have to have it negative, because if you look at both ends, what's it doing on the ends? They're going both down. Whereas what you saw in the window, you only saw both ends going up. So if the lead coefficient was a negative number here, and this degree is even, then I should be both down. So if I see only on my screen both up, I need to adjust my window. On those of you who have graphing calculators, how do you adjust the window? You go to the button that says Window. Okay? And just so that you are reminded of this, and I know it's been a while since we've talked about it, but when you hit the button Window, X minimum means left. X maximum means right. Y minimum, which again I can't spell, that's good enough. Y minimum means down, and Y max means up. So if you need to adjust that to make them go one way or the other, then that's where you would adjust it. How high or how far you go, that's up to you. It's to be determined. Some of you could have it different than others. Okay? Now, on the first part of your assignment, just so that you guys know what it's going to ask you to do, is it's going to ask you to fill in the blanks. That's what it's going to do. On page 342 is where it's at, just so that you know. This is number 28. It says 10x to the 4th. And what it's asking you to do is it says, describe the end behavior of the graph of the polynomial function by completing the statements. And it says, f of x approaches I don't know as x approaches negative infinity. F of x approaches I don't know as x approaches positive infinity. Now the difference with the way they wrote it as compared to the way I wrote it is I put the left and right first before the up and down. They just switched it around on you. It's not any different than what I had. So here's what you look at. This number first. Is that odd or even? Even. So just so that you know, if I go back to these screens, I'm either going to be this scenario or this scenario, since I'm even. Now I look at this number. Is that number positive or negative? Positive. So now look at the chart that I gave you, or the different slides that I had for you, and I said positive and an even degree, where does it go on the ends? Does it go up or down as it goes to the right or left? They both go up. Positive infinity, positive infinity. That's what you do for 28 to 36. You just fill in the blanks. You use the 4 slides that I just gave you, and I know you guys wrote them down, or most of you did anyway, and then you fill in the blanks with either a positive infinity or a negative infinity, depending on if it goes up or down, on the right or to the left. Okay? What do you think? Then, on 38 to 49, here's the directions. Graph the polynomial. So, when it says graph the polynomial, how are most of you going to graph these? Using your calculator. Absolutely. If you don't have a calculator, which I know some of you don't, what I would suggest that you type, or what you could do is you could use that direct substitution that we did last week, and you can plug in your own numbers, plot ordered pairs, and connect the dots, if you want to do that. Now, how many should you do? I'd say a good 20 of them would probably be the best if you're going to do it that way, because there's going to be some of these that turn so often that you're not going to know if it does it or not. So if you don't have a graphing calculator, I'd suggest putting 20 numbers in there. But if you do have a graphing calculator, you type this in. How do you type this into your graphing calculator?
Using the caret.
Well, first of all, what button would you push? Y equals. Now, my graphing calculator is in a different spot. So since I'm recording this one, I don't want to change that. So I type X, and then caret button, and then 3. Now, if you have a newer 84, like the 84 pluses or the newer 84s, if it gives you the shadow box, remember that you might want to hit the right arrow to get out of the shadow box once you've hit to the third. If you've got the older 83 or an older 84, that's exactly how you would type it. And then from there, you would hit graph. Now, if it doesn't graph, I can help you out with that because there's some of you that have changed windows before, or you still might have a scatter plot turned on from a different or previous stuff. But what should happen is you should get something that looks like this.
You just hit graph?
You just hit graph, right? Once you type it into your y equals, you hit graph. And is that what you saw? Roughly what I draw or drew? Yeah. Now, look at the end behavior. It's x to the third. So a 3 is odd. It's positive. So therefore on the left it should go down and on the right it goes up. And is that what's happening? Yeah, it is. Okay? So,
What button did you push to get there?
y equals.
Where was that? Oh, never mind.
There. So then you go x caret 3. There you go.
Thank you.
So I put this in.
Y equals.
Oh.
You're in the wrong mode. X caret 3. Got to be in y equals in order to get it. And you got a bad window. There you go. Now I got it. Okay? So, as far as the last part of the assignment on 30, what did I say, 38 to 49, all it is putting it in the calculator and seeing what you get. Be mindful of your end behavior. If all of a sudden this was supposed to be going both down and this thing is all you see, then it's probably going to loop around this way, which it didn't. And it shouldn't have on this one. But if that happened, then you might want to adjust your window. Okay? Now, how do you graph it? Well, most of you guys are graphing it in your graphing calculator. Then what you do is just draw what you see, roughly. Or if you've got a newer one like Hunter has right here, you could actually put this in or link or hook it up to your computer and actually print off the screens, but that's way more work than just drawing it on your paper. Okay? Do you want me to do another graphing one? So the first part of it is end behavior. All you're doing is filling in the blanks. Look at the different things I gave you, and you're going to match it to which one, and then you're going to plug those things in, either positive infinity or negative infinity. Then the last half of the assignment, you're going to graph. So, starting on page 342, 28 to 48, evens.